In this chapter, let me just cover a few concepts involving numbers and programming. Imagine that we have an odometer that's counting in hexadecimal, binary, and decimal, and we begin in 0. If we begin counting up, we're counting up 1, 2, 3, 4. But what would happen if we took that odometer and went backwards? Then we would find that we would get 1, 1, 1, 1, 1, 1, 1. This then must be -1, or in hexadecimal, FF. We remember that we agree that if the most significant bit in a binary number is high, or 1, this number must be negative. If we continue counting from 0, 0, eventually we will get to the number 7e, which is 0, 1, 1, 1, 1, 1, 1, 1, or 127. If we add just one more number, we get to the number 80, 1000000, which is normally 128. But because the most significant bit is high, we are going to agree that this is negative 128. The conclusion is that with an 8-bit microprocessor, we can count forward to 127, and then we can go backwards to negative 128. Here is a program that originates at 0120. And then when I get to 0140, I'm going to call out what's known as a label, which is like a placeholder. My program will continue, but when I get to 01CD, I want to execute a command called branch always. And what I want to do is branch back to blue. At 01CD, the microprocessor executes the branch always command. And then at 01CE, it actually executes the blue command. And then finally at 01CF, I need to insert a negative number such that when I add it to 01CF, I will get the number 0140. We claim that if I take the number FF80 and add it to 01CF, the microprocessor will be at 0140, and therefore it'll jump backwards to a certain location which I had labeled blue. The question is how to derive the negative number FF80. Let's take the number negative 128 and begin with positive 128, which was 80. Let's take 80 and add 8 leading zeros because the program counter is in 16 bits. We follow the procedure we've done before where we take the ones complement and take the opposite of each digit and then add a 1 to it, and the result is we get the number FF80 in hexadecimal, and this, as we agree, is going to be a negative number. What we have done in this example is we have calculated how far backwards the microprocessor can jump. And now we see that we can jump backwards 128. It doesn't seem like much, but when you're programming at this low level, which is really assembly language, 128 is a long ways to jump back. One final concept in this chapter is the table 4.6, which is contained on page 101. The microprocessor makes certain decisions based on certain flags which are contained in the condition code register. And these flags tell the microprocessor, do you have a negative, do you have a 0, do you have an overflow, etc. It takes some getting used to, but the branch if not equal command looks at the Z flag, which is the 0 flag. If the flag is low, it means that there is no 0. In the branch if equal command, it's the opposite. Again, you're looking at the Z flag, but if the Z flag is high, it means yes, there is a 0. One last command is branch if lower than, and what you're doing there is looking at the negative and the overflow flags. But this time you're looking for is it high but not both. And this command will be used when you're using exclusive OR commands.